Hello guys, thanks for joining my quick little training on how to set up a distribution node to a client node. This will be the Terragraph default setting. Actually, the Terragraph mode is a mesh and hybrid mode. It'll automatically go into hybrid mode if there is no true IPv6 present on each end, depending on how you set it up. It'll automatically create VXLAN tunnels for you, so you could then have traffic, IPv4 traffic, on the on both ends of from your DN uplink to your CN downlink from end to end. So I'm going to go over that. So starting now. Okay, so the first thing I want to point out to do is to get the CNs, the client nodes, get those first, and get them all programmed and firmware upgraded and all the things we need to do. So first thing to do is log into the CN. Now, why am I doing a slide on this? Well, one of the first CNs, the firmware 1.0.0, we had an issue where you need to actually do a reset via SSH. There was a little issue in the factory where they didn't get the radio reset and able to log into the GUI. It was a little issue. All you have to do is just go in there via SSH and do a JSSF to reset -y command, and you're good to go. So it's only on 1.0.0, and after you've done that, then you can get into it. You'll notice the GUI will come up, but you put in the username, password, admin, it doesn't work. So that's your dead giveaway. Another thing to point out, and this happens occasionally, is on Google Chrome, we've seen some issues where the browser wouldn't come up, or the actual, the web page of the device wouldn't come up, and it just seems to be a Google Chrome issue. If you're able to ping it, and but not able to pull it up on the browser, just try a different browser like Edge, Microsoft Edge, or something different. Should be able to get into it. Also to point out, the ways to get into it are two different ways. Let me go to the next slide. So assuming you already have either later than 1.0.0 firmware and you don't have to do that reset, or you've already done it and now you're able to get into the device. Now the next step is actually to get into the device is going to be 192.168.1.20 if you're connected to the PoE LAN port. Okay, if you're connected to the PoE secondary, I should say the LAN secondary LAN port on the radio, on it, that's actually 2.1. So you can log into it either way, but just realize which port you're connecting to kind of determines which static IP address the radio is defaulting to. So again, 1.20 for the PoE LAN port, that's most common what people will connect to. So of course set your computer to like a 1.10 IP address to talk to it that way. And then the username and password is admin and admin to get in. All right, the next thing we recommend to do is reset the, or actually set the firmware, upgrade the firmware. The default firmware, definitely don't want to use that. And also, there's a primary and secondary alternate boot bank. There's two boot banks. So the thing is, we don't want to have really old firmware as the alternate boot bank. So the latest firmware now, currently in this video, is 1.3, but you don't want to have 1.0 as your secondary bank in case there's some sort of issue that would cause it to fail over to 1.0. You want to load both boot banks with 1.3, and the way to do that is to just load the firmware twice. So it'll kind of flush out the oldest one, and you'll have both 1.3 in both banks. Now going forward, you could just lower it in. Let's say there's a future 1.4, you could load that in. The alternate would be 1.3. That's probably okay, but we want to clear out the really old firmware. And then after you've loaded the firmware, best practice, factory reset the radio. There's been a lot of changes and updates that going from 1.0 to a much later firmware, you want to reset the radio just to rule out any nuances. Okay, next thing to do is, okay, so on the 1.3 firmware, we added a feature where you could bind the port together on the PoE LAN port. They're actually, the management port and the LAN port, or the data, if you will, were out of band or separate. So that was an issue because you'd have to run two cables to the device. for PoE management, another one for data, if you will, downstream off the LAN, the secondary LAN port of the radio. But the most common thing you'd want to do is just run one cable to the device. If you're on a customer side, of course, you'd want to just have one cable going, basically the PoE out up to the radio. And how to do that, you just change the uplink port role to LAN port. It actually binds the management and LAN together. So when you do that, then you're just running one cable for both, but also realize that now the LAN static IP address changes from 1.20 to 2.1. You could change that, but just realize when you do change the setting to LAN port, that then your PoE up port or your PoE port, LAN port, becomes now 2.1 as your IP address. If it's DHCP, your failover would be 2.1, but you could again certainly change that. Okay, next thing is to record the wireless MAC address of the radio. So there's several MAC addresses, actually 3, right? There's 2 Ethernet ports that have MAC addresses, and there's a wireless radio MAC address. So we want to note the radio MAC address because that's what we're interested in telling the distribution node to connect to, that wireless MAC address of that radio in the next steps. So the best way to get it is just log into the local GUI. I mean, you're going to have to log into the radio to do a firmware upgrade anyways. So just get it there. That's the best way to get it. There are other ways of getting it. There's 2 ways. Other ways, you can go to the device itself and go to the node MAC address, the Ethernet MAC address, which is the bottom left picture there, and then add hexadecimally 2. And then the other option is on the box. Get the MAC address that way, and then hexadecimally add 2. So that's how you would get the same thing. You want to get them for all. Let's say you're going to install, let's say, 20 CNs. You want to get a list of all the 20 wireless MAC addresses for future entering into the distribution node. So that's here where you note all of those. It's easier to get it from the GUI because then you can copy and paste it from the GUI and not have to write it, make sure you got it correct. Okay, next thing is, okay, now we got the CN figured out. We got the firmware updated. We can log into it. We got the wireless MAC address. We got everything on the CN, so we can set those aside. Next thing is to go to the distribution node. Now, first thing is just, of course, log into it. Now, there's no nuances as far as doing any resets. It's going to work. It's going to be 1.20. The thing is a little different, though, with this than you're maybe familiar with is it's also going to have a separate out-of-band management versus uplink or data. It's going to be separate. So, and that's going to be the way it is. You can't change it on the distribution node. It's part of its design. So keep that in mind. So the PoE in or PoE LAN port is your management port. And that's what you'd use to talk to it with getting into it with 1.20. It will pull DHCP if you have it behind a router, so you can get it that way too. Whatever IP it gets, that way you can get into that way. So either way, and then logging into it's just admin and admin as well. Now, in this example, you see the DN requires 2 cables, one for the PoE management and the other for data uplink, and they are out of band. So meaning, okay, so which ports can you use for the data uplink? You could use the SFP plus port, the 10 gig port, which by the way doesn't do 1 gig. We'll ask, can it do 1 gig SFP? And it's only 10 gig fixed. Or you could use LAN 1, 2, 3, or 4 1 gig ETH ports. So you could have a 1 gig Ethernet port uplink, or you could use the SFP plus port. So either one. All right, next thing to do is, of course, load the latest firmware 1.3 currently. The thing is with the DN, you have to do an intermediate step with 1.1.2. It won't let you load, say, 1.0 or older firmware than 1.1 or so with the 1.3 or later firmware. It has to do with the file size issue. It's just the original firmware wasn't set up to handle a larger file size that the newer firmware is. So it's just another step. You have to download. You should go to the website there. You go to Google. You type in MLTG-360 firmware as a search, and it'll come right up, and you can download the firmware. You should download firmware 1.1.2 and 1.3 in this example, or whatever latest firmware it is at the time. But you'll have to do that intermediate step. And then, so that really means loading firmware 3 times. It'll be loading 1.1.2 and then 1.3 twice. So both banks are 1.3, and then you do a reset on the radio. Now, going forward, like I said, you could probably just keep the older boot bank with the older firmware because it's more, at this point, we're further along. The firmware is a little more mature. Okay, now next step is to set the pop node, generate IPv6 values, and set the control VLAN. Okay, so these are not the pop node, or they're not set up to be the main mesh node, the main mesh node. It's actually set up to out of the box to be a secondary node, or one that would be wirelessly connecting to a pop node. So we want to change it to pop node. So this will be the DN where internet is going into it. So it'll be the main distribution point. So we want to turn it on as pop node. So default's off, we want to turn it on. The next thing we do, once we turn it on, you'll have other options that'll come up, and you'll see that it'll say using dummy IPv6 settings generate. So you want to actually generate the IPv6 values. These values are required for the OpenR internal network to work. This is how it's also required for the VXLAN tunneling to work, and how we call it in hybrid mode. This pop node, this distribution node, is acting as the OpenR actual service. It's actually doing it, and it's an internal IPv6 network between the DNs and CNs are happening, but it'll be tunneled through VXLAN, and therefore the IPv4 traffic from end to end can occur. But these values are required, even though they're not really important, because it's all internal. You do have to have them. Now, it's different than full IPv6, where these values actually then become, you're not doing a local controller mode, and you're actually doing full end-to-end IPv6. That's different. So just go ahead and click generate, let the values be there, and then the last thing is the control VLAN ID. That's required. It's not really important, but actually put in a value that you don't use. It's actually for if you're using like the Facebook NMS, but it's not required for this. So just put in like a value of 100 and or whatever you don't use, and you can just move on with the next step. Okay, now the next step is to enter in all the wireless MAC addresses of all the devices you're going to connect with this DN to. So in my example with the 15 CNs, you'll have like say 15 wireless MAC addresses. So you're going to systematically add one by one. You're going to add them all in, and then put them all in. You'll have 15 entered in this step. It'll be in your topology nodes setting page. After you've done that and you entered them all in, again, this is the wireless MAC addresses of the CNs. You'll go to the next step, which is the topology links page just below it. So in link settings, you create the links. So now with all these nodes that you have to work with, you're going to now build your links. So, and you'll have a huge list here. An example is just what's circled in red, the CN1. You're going to have a huge list, and you're going to slowly build them all. Now, you still have to systematically do them one by one. You add, and then create a link and save. And the reason why is so there's no conflicts, because if you were to, say, build a link that doesn't make any sense, it's going to catch that and stop you from doing that. So you have to do them one by one. So, again, here, systematically create the links. Now, keep in mind the distribution node has 4 radios if you have the 360 model. They're 90 degrees each. So there's radio A, B, C, and D. So you have to select when you're doing these, you're going to select on the DN side which of the 4 radios that this, say, CN that you're going to create the link for to which one. You have to choose, radio A, radio B. You have to enter in the correct one. So just keep that in mind. I'll give you a little suggestions on ways to keep track of which radio is which in later slide. After you've done that, then basically you're done with that. They should start coming up. If you've created, say, a line of sight scenario in a lab and you want to verify this, in other words, stuff should start linking up. On the couple ways you can check and verify the links. The best way is to go to the dashboard and topologies page. That's where the real information is. In this example, I have a -63 signal. Channel 2, power's 41%. Now, keep in mind the MCS rate of 9 is the connection it's shooting for. It actually doesn't default to try to go to MCS 12 unless there's more traffic being pushed. So it actually throttles its power based on the demand. So MCS9, you'll notice that maybe the power is not all the way up, or your signal's kind of weak. Let's say it's negative 63, but I should have a negative, let's say a better signal, right? Because you know it should be stronger. It's going to throttle down the power, so you won't necessarily see the best RSSI based on your signal. It'll do whatever's the required power to maintain an MCS9. Now, if you start pushing a lot of traffic, you might see it go up to MCS 10, 11, 12. So that's kind of how that works. So just keep in mind why you may not see this RSSI what you'd expect it to be. Now, as you get further and further out, and the power requires more to maintain MCS9, then you might actually see more closely the power go up and the RSSI match kind of what you'd expect it to be based on your link budget. Okay, the other thing is you could check the link on the CN side. The blue light for 60 gigahertz will then light up. It's linked up. It'll show blue. That's another easy way to know if you're linked up. The other thing is in your topology links page, the green, the little icon there will show. It'll show green. It'll show that it's linked up there as well. So there's a couple different places to verify your links. Important to note, there's two things needing to go on because this is a VXLAN tunnel. You got two things in order for traffic to occur. You have to have the RF link, obviously, but secondarily, you have to have the VXLAN tunnel. And once you've got these going online, it takes a few minutes. So hang tight. You'll usually see the RF links established first, then maybe within a minute or two. Sometimes it takes 3, 4, or 5 minutes for everything to kind of get going. Then the VXLAN tunnels are created. Then your now IPv4 traffic from end to end can occur. The tunnels obviously have to occur for it for the traffic to go through. So just keep that in mind. You could verify there in this in the dashboard topologies page that for the VXLAN tunnel. So you're actually verifying two things. You're verifying the tunnel and the RF link. Okay, so I'm going to give you a couple other little quick extra tips. One of the things on the DN and CN, you'll see there's no physical reset button on these. So how do you reset the radio? If you go into System, and you'll see that there's actually it'll say number of boot retries for factory reset. So that's it, 3 by default. So that's what you do. You power cycle the radio in like 5-second intervals 3 times to initiate a factory reset. So that's kind of how you would do that, CN or the DN. Another thing is, okay, so I mentioned, how do you know which radio is which? So you'll see in the quick start guide, there's drawings. Even in the radio itself, in the GUI, there's a drawing of like which radio is which. So there's just showing here what it is. I like to label even the outside. I draw a picture. I just got a marker and literally wrote it on the outside there, A and C. In the example there, and of course on the other side it's B and D. But so I know which one I'm working with. I think it's also a good idea, just a suggestion, is to make it a best practice to position radio A to due north, right in the middle, as best you can. Then later on installs, maybe a year later you got to install another client node, and you can it'll be much easier for you to keep track of which radio it would be to connect to. So I think you should just do all your networks and all of the same, stick to that, radio A north. Of course, this doesn't really apply to the DNs that are not 360 degrees, but just an idea if you're using a 360 degree for radio DN, that'd be an idea for something to do. And the last thing is the connecting to the cloud. So in 1.3 firmware, the later firmware, it'll support connecting to the cloud. But it's default off. So what you do is go into System to turn on the cloud agent. So now also on the cloud, now if you're just seeing this little training and just recently, the cloud doesn't support the MLTG devices yet. It's going to be in a next, from what I hear, a few weeks from now. So keep that in mind. You may have the 1.3 firmware, but you can't add them to the cloud yet. So just hang tight. It's going to be right around the corner for that. You'll know by trying to enter in the serial number and MAC address. It won't take. So just it should be soon. Now, let's say now this is you're hearing this recording a little bit later, and you're able to add them to the cloud. A couple little things I want you to be aware of. When you add it to the cloud and it goes to a site, There is a local logins tab within the your site menu options, which has a username and password. When a device connects to the cloud, it assumes the new site username and password for the device. So you won't be able to log into it. Let's say you had admin and whatever your password, I can't log into it locally anymore. Well, it's actually on the cloud now, and it's got a new password from that. You could actually set that password. You could even make it the same password, but just realize when it's on the cloud, it pushes a new password down to the device for the locally logging into the device. A couple other things. The cloud is cloud.ignitenet.com. It's free. You could do your link calculations for 60 gigahertz, like estimate your link with signal strength with and without rain. You can do that. That's free as well. And it's free for up to 50 devices, so it's quite a bit. So, and if you happen to have more than 50, then the cost is just $99 per year. So it's not very expensive. So, all right. Well, thanks for listening to my quick little training. If you have any further questions, you could email support at edge-core.com. I'm Dan, and from Ignite at Edgecore. Have a good day.